Welcome to Microlecture 21, where I will introduce sources of strain in small ring systems. Okay, so we're going to be talking about 3-membered, 4-membered, and 5-membered rings. The first one is a 3-membered ring that would be called cyclopropane. And the issues with cyclopropane is that being that there's 3 carbons in the ring, it is planar. A plane is defined by 3 points, so it has no choice but to have all of its hydrogen atoms and carbon atoms eclipsing one another. So first, let's talk about this tremendous amount of angle strain. An ideal tetrahedron is 109.5 degrees. And what we have here is 60 degrees. So these bond angles are under a tremendous amount of strain. If I tried to build this molecule with my kit that I showed you in a previous video, it would break my model kit. Your smaller model kits that were recommended for you to use are flexible enough to actually build it, but what you would see is the bonds would actually have to bend, and that's true for a cyclopropane molecule. So they're very weak bonds because they're so strained. Now, meanwhile, while that strain is going on, we can't do anything about this eclipsing strain because cyclopropane must be all in one plane. So the eclipsing strain is unavoidable. And so the resulting structure is very high energy. Then we get into 1 carbon larger, that's the cyclobutane. Here we have 90-degree angles, and that's only if it's flat. And so what can happen here is that the molecule folds up, and the image on the right-hand side just doesn't show it quite as well as a model kit if you had one and you can build it. And you can fold carbon atoms sort of out of the plane to try to stagger hydrogens away from each other so they're not eclipsing each other. You know, the bond angles are good if the molecule is flat, but we compromise here and reduce the bond angle to about 80 degrees by folding the structure. So we spend some angle strain to prevent eclipsing strain, which is going to be very, very costly if we don't fold the molecule up a little bit. Now, it turns out that the larger the molecule gets, the more freedom it has to fold or bend or pucker, and so that's exactly what cyclopentane does. It puckers up. If you could think of this carbon right here as being able to fold up like the flap of an envelope. That's kind of what we're talking about here. And again, we're going to spend some angle strain. Angles are reduced from what would be, a pretty ideal situation. It would be about 108 degrees in the flat structure. So we're going to make those angles a bit smaller and spend a little bit of energy there in order to prevent, again, the very costly eclipsing strain, because in a flat structure, all of the carbons and hydrogens are eclipsing one another. What we're going to see next is cyclohexane. So 6-member rings are so fascinating. They can bend into so many different conformations of so many different energies, and so we're going to spend the next few micro lectures talking about them.